Welcome back to BT. We're told to get a flu shot every year to protect us. But what if we could just get one shot to last a lifetime? Craig Jenny, an assistant professor of microbiology, immunology, and infectious diseases at the University of Calgary, is here to tell us about exciting influenza research underway right here in Calgary. Good morning to you, Craig.
Morning.
Nice to see you again.
Yeah.
So why are we told to get this flu shot every single year?
Yeah, flu is one of those tough ones. It changes every year, so it's sort of a professional shape-shifting virus. So if you had the shot last year, good chance that the virus is different this year, and we know it is again, so we need a new vaccination.
You need a new vaccination. Yeah. Okay.
Yeah.
Well, at least you're saying that this year the vaccine's a pretty good match.
Yes, so far all the data coming in, really good match this year, so we should have really good protection if you're immunized.
Okay. So explain to me exactly how this works. So when you get this flu shot every year, what exactly happens in your body?
Right, so what we do is we actually show your immune system some of the proteins on the outside of the virus. And what we do is we build molecules that bind and neutralize, so the virus can't get into our body. So unfortunately, when the virus changes its outside, now we can't neutralize it, and we need to reboost the immune system with a new vaccine.
Every year?
Every year,
okay.
Yeah.
So wouldn't it be nice, though, this idea that one day there might be a universal vaccine?
Yeah.
There is some research in this
area.
area.
We're getting closer to it. So it's a sort of different strategy where instead of showing the immune system the outside of the virus, we show it the inside.
Oh.
And that part of the virus can't change as much. It needs to do certain jobs. So it has less flexibility. And if we can find things that the virus can't change and teach our immune system about that, we can sort of anticipate every year's virus and have some long memory.
For sure.
Yeah,
Make it last for a while, right?
Yeah, exactly.
So where are we at with that research, though? That's not really anytime super soon.
No, it's still a few years off. Some human work being done on looking at patients who've had the flu and who's recovered and what their immune systems look like, and then moving those into some animal models, mice, and testing how well it works and building the right vaccine before we go back into people.
And back into people. Okay. Now, but your lab is doing some pretty interesting research on a whole other way of looking at this, isn't it? So tell us a little bit about that and the immune response to the virus.
So we've come at it from a different angle, that if the virus keeps changing, what part doesn't change? And the part that doesn't change is us. And we ask, well, how does the virus cause damage? And a lot of the damage is our own immune system trying to clear the virus. So we're looking at actually regulating our own immune response, ignoring the virus, and trying to, promote viral clearance, but protecting our own tissues.
So what do you mean by that? So what is our immune response doing? What are we seeing in our body? What are the symptoms?
So things like inflammation, and we get that in our lungs, and what we're doing is we're actually trying to kill the cells that are infected with the virus, kill the parts of our body that are infected with the virus in an effort to get rid of the virus. But as a result, we do damage to ourselves.
Okay, so what does that look like symptom-wise?
So that's where you're getting the cough, and you're getting fluid in the lungs in the severe cases. People that have to go to the hospital end up with like a pneumonia. So if we can stop that, our immune system will get rid of the virus, but what makes us sick is often our own
immune response to it.
So we're trying to dial that down just a little bit, keep it under control, still clear the virus, but hopefully protect our lungs and other tissues.
And how would you be able to do that? Would that also be a vaccine type situation?
No, this will probably be a medication you receive after you're infected. So, most people will clear the virus fairly well. Most, young people do okay with the virus. It's just as the disease gets worse, as the sickness gets worse, we would have a way of intervening and hopefully lessening the sickness.
The immune response.
Yeah.
Okay, so just out of curiosity, and I'm just throwing you a question totally out of left field, but if you're targeting the immune response to the virus, could that not translate into all other kinds of diseases?
Yeah, exactly. Yeah. So we're hoping, that the idea is our immune response is really good at clearing infections, but we're always willing to sacrifice a little bit of our own body. With medicine today, modern medicine, we have antibiotics to deal with bacterial infections, but our immune system's still causing damage. So if we can separate the two, we can make current drugs work better while protecting our own tissues.
Wow, that would be amazing.
Yeah.
Incredible. And that's happening right here at the University of Calgary.
Yeah, there's a bunch of us in Calgary that are working on that, inappropriate inflammation and controlling it. The other one is inflammation is what repairs tissues after you've had surgery or an injury. So if we can, again, better control that, we can improve recovery after certain conditions.
Wow, that sounds really exciting. You'll have to come back and tell us all about that when you've got something to tell us.
For sure.
Craig, thank you so much for being here.
Thank you.